Hi there. Today we're going to take a look at the Pico Pi and we're going to run our first program on it. So this has already been flashed with firmware and it's ready to go. The program we're going to be used to bring Pico Pi its code is going to be Thonny. You can download Thonny from this location. It's just thonny.org. It runs on Windows, Mac and Linux, and these instructions should be pretty generic for everything. So if we get rid of this now, first of all we need to be able to run code on the MicroPi itself rather than using the internal interpreter. So what we're going to do is just make sure this is plugged into USB and that it's been detected, and then we're going to click on Run and select Interpreter. And then we're going to click on this drop down list and we're going to go to Raspberry Pi Pico. Once that's selected, we just leave it on Detect Port automatically and click on OK. As you can see, the shell has loaded up here. The shell is where you can execute individual commands. So let's try a classic one, which is Hello World. All we're going to do is type in print, quote, Hello World, close quote, and close parentheses. And as you can see, it's repeated Hello World there. So this program is actually run on the dual core processor on this board. So all the resources in this board are being used to run it. All this console is doing is mirroring back what's happening. So what we want to do now is make a program that's a little more interesting. So the first thing you need to do is work out how to view the files on your device. And you can do this by clicking on File and then clicking on Files. And then this side panel will come up. And as you can see, we have a main.py file right here. So we can access it simply by clicking it. As you can see, I've had a rather complicated program running before. If you find pre-existing code on your device, all you got to do is right click on py main and click on download to, and this will download it to your local machine. Then we can actually just delete this. So if you right click on it and click on delete and then click on yes, that will get rid of the file for us. Now we can close down main.py. Now if we click on new file and we save, we can save to the Raspberry Pi Pico and we simply call it main.py. Once that's done, you'll see that a new main.py has been loaded on there. Now I could have just cleared off all the code, but I wanted to show you how you basically manage and create files on the Pi Pico. Once you've done that, it's time to create your program. We start by entering this first line. What we're doing here is we're importing some libraries that Python will then use. We then create a variable called LED and we set it to pin. It's set to pin 25 on the GPIO. So if you look at the bottom of here, you'll see that there's lots of numbers, GP1, GP2, etc, etc. This is indicating which of these pins is becoming active or not. And when it's out, what it's basically saying is that it's outputting a voltage to that pin. Next, we're going to create a timer variable and we're going to assign it to the timer function. We're going to define a new function, def blink timer, and this function has one purpose, which is to toggle the LED. Spacing is very important in Python, so you need to make sure you follow the same structure as well. Finally, we call timer init. We give it a frequency, which is the speed at which the light will flash, and we set it to mode timer periodic, which means it's going to keep calling back the function. And it's going to call back the function blink, which we defined here. So now, if we save this code and run the script, you'll see that the LED on the Pi has just started flashing. That's because our program is triggering pin 25 and sending a voltage out. This LED is connected to pin 25, which makes it a very good indicator tool. If, for example, you wanted to make sure that this device was powered on, then you could simply run this program to indicate it there. If you are writing data to the program or logging something and you wanted to rewrite data, then you could just reference 25 and it will flash to whatever you want. The point is that this pin is ready to be set up for any feature or function you like. It's up to you how you choose to use it. We can quickly and easily change the frequency of this, and if we click on stop, by the way, you'll notice that the LED is now stuck in the on mode. So if it's off, it will be stuck on off, and if it's on, it will be, well, stuck on, as it is now. The reason being is just being given a command to turn it off and on, off and on, off and on. Whatever point you pause that program, it won't turn itself off because you haven't given it the instruction to do so. If we wish to increase the intervals between flashes, for example, you could have different status messages programmed into a program that give you different blink codes. In this case, we're going to try blink code by changing frequency to 5. I just did a Control and S on the keyboard, and now when I click on this play button, you'll see that the blinker is now going much faster than it was before. If you want to slow this down, we simply decrease the frequency. So if we stop here and set this to 0.5, again I hit Control S on the keyboard, I hit the run, and now that LED should be on and off for a much longer duration than it was previously. And that's it. That is how you can program different blink codes into your board. So if something goes wrong with your program, you can actually diagnose something very quickly just by using this onboard LED. I hope you've enjoyed this tutorial, and I hope you'll come back for more. Please like and subscribe for more content.